Okay, g'day everyone. As promised, I apologise it's taking so long. This is the first in a series of videos that I'm going to be putting up over the next couple of days. I'm going to be covering the main tests that are associated with the project, so performing a OneWayAnova, a TwoWayAnova, regression analysis and a GLM. Given that obviously I'm going to put this on YouTube, well, as you know, this is on YouTube, so they can only be roughly 10 minutes in certain sizes, so I'll do a video for each of them. Okay, so starting off with, we're going to look at an ANOVA, and just to start off with, an ANOVA is a test of equal means. So prior to the ANOVA being introduced, if we wanted to analyze the similarity or the dissimilarity of means between two populations, we use something like a z-test or a t-test or something like that. Obviously, when this gets expanded so that you have more than three populations, or more than two populations, in order to analyze whether or not they all have equal, say if we were just looking for equality of means, we would have to do, bivariate tests between each of them. So say there was 1, 2, 3 population 1, 2, and 3, we'd have to test 1 with 2, 1 with 3, and 2 with 3. So in order to save us from having to do that, we can do an ANOVA which does one test to see if population 1 is equal to population 2 is equal to population 3. So it does it all in one, which is nice. The only downfall of it is that we don't know how they're different. All we can test within an ANOVA is if all of the means are equal, or if there is one that is dissimilar or multiple that are dissimilar. So I'm just going to go by the prac material. So we're just going to just jumping into prac 6. This is just on Blackboard. So I'm just going to open this up. I hope everyone can read it. I'll zoom in a little bit. I'm not sure how clear it will be on YouTube. But anyway, yeah, we might have a look at actual two-way ANOVAs here. I just want to jump and grab the data. So they're working with the performance of lifts. Okay, so let's just grab a copy of that data. Performance, where are we? Goodwill Bridge, where am I? Let's say performance of lifts, here we are. Okay, so obviously I'm going to open this with Minitab. Right, okay, and so it's got a copy of all of the data. Now, whenever you're dealing with a OneWayAnova, there's a certain setup that is required. Obviously, you need to introduce the problem. Now, an ANOVA is when we're dealing with a continuous variable, and we want to analyze its relationship with a categorical variable. So as an example, if we have a look at the data that we've got within here, I'll just do one. If we look at time of day, we've got night and morning. Is there any other intervals? And then in direction, another categorical, they just seem to have up and down. Maybe, what about the building, L, M, O? So, okay, we'll look at how, say, the time in seconds is affected by the building. And so what we're actually testing when we do that, and by the way, you need to write out the null and the alternative hypothesis, is in this situation, we want to analyze is the mean of, so L, so the different values of L, M, and O. So the mean of L is equal to the mean of O, which is equal to the mean of, sorry, my memory's shocking, O, M, and L. Okay, mean of M. And when I say the mean, this is just something on the side, it's the mean of the time. So when I say time, I am referring to this time here. So we want to see whether or not, if we split these into 3 separate categories, so the building, when the building is equal to M, and the building is equal to O, and the building is equal to, oh, there's also Q there as well, and S, so there's quite a few buildings there, sorry, is the average time equal? So there's actually a lot more than what we've got here is equal to the mean of Q is equal to, and dot dot dot, so all the rest of the means. The alternative hypothesis is just at least one mean is different. Now, as I was saying before, this analyzes whether or not analyzes the relationship between the continuous variable versus the categorical variable. So in our situation, the continuous variable is the time in seconds versus the categorical variable, which is building. So if it didn't have any effect whatsoever, so it didn't matter what building you're in, you should have the expected, or on average you should have the expected amount of time, then what we should find is that the H0, i.e. that the averages, should all be the same. If, however, the building does have an implication, then we would assume that some buildings would have a much quicker time, some buildings would have a much faster time, quicker, and some would have a much slower time, and therefore their means would be different. So if it ends up being that the actual null hypothesis is accepted, that means essentially, it doesn't mean definitively, but this test then provides one way of saying, well, there isn't a strong relationship between that categorical variable with the continuous, or building, for this example, building and time in seconds. So H1, as I said, you can word it however you want, but just at least one mean is different. And you should write exactly what we're talking about. So mean time is different for a single or multiple building. Okay, so we're going to perform a one-way ANOVA in order to do that. So let's just do that. This is quite simple. You just go to stat ANOVA one way. The response variable is the continuous variable. So in this situation, that's the time in seconds. The factor is the what you want to split it up on. So in this situation, the factor is the building. Now, in terms of the graphs, you could do individual plots. I like to just put 4 and 1. We definitely need this output. And then you just click OK. The confidence interval of 95 you can leave as it is, and that's all you need to do. So one way ANOVA, very simple and easy. So we click OK, we get this output, and we get this. So we get the the output of the actual analysis, which is what we see here, and then we've got some visual analysis, and we require both when it comes to the project. So just to save time, you can just highlight over the data that you want. And the nice thing about Minitab is you can right click on it and you can go send selected lines to Microsoft Word, and it'll go to whatever is the open Word document. So you can see that that's been copied over to here. So we need that, but we also need this plot within here. So again, right click, send graph to Microsoft Word, and we see that both results have come in. You can rescale these so that they fit and whatnot. They don't have to be that big. That's purely entirely up to you, just as long as it's readable. Okay, so I'm not going to go into detail exactly for this example how to interpret it. I'm just going to talk about what you actually need to interpret. The key things that you need to discuss is obviously the p-value. P-value first and foremost. So this value within here, this value tells you whether or not you're going to accept the null hypothesis or you're going to reject the null hypothesis, and therefore that implies accepting or rejecting the alternative. So we need to talk about the p-value, to talk about which hypothesis you will be using, for lack of a better word. And then once we've done that, we then need to look at the R squared and the R squared adjusted. So the R squared and the R squared adjusted. And then, excuse me, this is important, but there is actually another test that allows you to analyze it. The next thing we need to talk about is the assumptions that are associated with a one-way ANOVA. So there are two assumptions for a one-way ANOVA, and this also holds for a two-way ANOVA. The first is that the residuals are normally distributed, and the second assumption is that excuse me, that the variances are equal. So when I say that the variances are equal, for this application, for this example, that would mean that the variance of L is equal to the variance of O is equal to the variance of M, etc., etc. So the variance for each of the buildings is the same. So one thing, if we find that either or of these assumptions are found to be invalidated, that doesn't necessarily mean that the results that we've got from the one-way ANOVA is wrong. So, sorry, let me restate that. I think I made a terrible case of that. If we find that the residuals aren't normally distributed, or find that the variances are not equal, that just means that the results of the one-way ANOVA may not actually be correct. So we can still write up the conclusion and the results of the one-way ANOVA. However, we have to include that given that assumption A or B or A and B have not been satisfied, we cannot be confident with the results that we get from the one-way ANOVA. So this is the results component and this is the assumptions component. So how do we identify whether or not the residuals are normally distributed? Well, these two graphs give us a good indication of it. So this is just a histogram of the residuals. Now, if they're normally distributed, obviously we're going to have something that's going to look like a normal distribution, which is what we've got here. It's a bit choppy, as you can see, but it still seems to resemble a general normal distribution. Another way is to look at these normal probability plots. Now, I'm actually not 100% sure how they do this, but I can tell you how to interpret it. This straight line that comes up in blue represents if the residuals were perfectly normally distributed. So in the perfect case, which never happens, or very rarely happens, all of these red dots would appear on this line. So what you need to talk about is how close these red dots are to this actual line, which represents, again repeating myself, sorry, perfect normality, and then you need to comment on how the residuals are also distributed. So we have a look here, we've got the residuals versus the fitted values. Now what we're looking within here is we want to see a random scattering of the values. Now these lines clearly represent the different buildings. So this would maybe be L block, O block, M block, and so on and so on. And so that's why we've got these lines with all of these different values. Now what you would want, it's very difficult to, well, it's not very difficult, but it's a little bit more difficult when you're dealing with a situation like this when they are in straight lines like that. But what you want to identify within that is there any patterns that are emerging, any sort of predominant curvature or any sort of, or it doesn't have to be, just anything where there's a pattern. So what I mean by that is if I just open up Paint to do an example, so here we've just sort of got them randomly scattered, but let's just say they looked like, and I never use Windows, so they look like this. Right? So let's just say instead of it being randomly distributed like that, we had something that looks like this. In that situation then, it does look as, oh, I'm not using the right one, whoops, that there is some sort of a curvature or there is some sort of variable that's going on within that. If that was the situation, and this is also very important with regression analysis, we would then have to look at the model in more detail. Okay, so in this situation, in terms of how you identify whether or not the residuals are normally distributed, it's just basically interpreting these graphs. Also, we want to have a random distribution of all of these. We don't want to see a pattern within the residuals versus the observation order. Okay, so the last thing that we need to look at is to do a test of equal variances. This is quite easy to do. So we just go stat, ANOVA, where are we? Test for equal variances. The response again is the time in second. The factor is building. That's all it is. Comes up with a graph. So I'm going to right click, send graph to Microsoft Word. So let's go into there. Okay, now we see that there's we've got two tests here. Just starting off with this, each of these dots represent the standard deviations for each of the different buildings, so B, L, M, O, as you can see here, and these are just the 95% confidence intervals for each of them. Now obviously if they are equal, we want to have these dots to be as close to each other as possible, but we see that there's definitely a little bit of difference with these two. These two seem relatively similar. This one and this one seems relatively similar. This one and this one seems relatively similar. But when we bring them all together, it seems that no, there does seem to be quite a lot of dissimilarity within it. So the two tests that can be done, or that is done for you, is Bartlett's test and Levine's test. We're only using, so only use Levine's test. That's all you've been taught to use. And Levine's test is set up like this. So the null hypothesis is that the variances, so the variance of O is equal to the variance of L is equal to the variance of M is equal to ... for each of the buildings. The alternative hypothesis is at least one variance is different. So you could word it a lot better to that. I just wanted to give it to you so you know exactly what you've got. So all you need to do in terms of being able to determine, which of the two hypotheses you're going to accept is just taking the p-values. So in this situation here, as the p-value is less than 0.000. In this situation, we have very strong evidence to accept the to reject the null hypothesis. Thus, the variances are not equal. Okay, so as I was saying before, in this situation here, with the OneWayAnova that we performed, I would say that we're fairly confident that the residuals are normally distributed, but we found that the variances are not equal. So in this situation, as I was saying before, you just need to write something. So, this as the assumption of equal variances has not been satisfied. We cannot be confident in the results of the OneWayAnova. So as I was saying before, it does not mean that the results of the OneWayAnova are incorrect. We just can't state that they are correct with confidence because we haven't satisfied that. Okay, so that's all I'm going to do for this video. I'm going to tomorrow I will release a video for 2WayAnovas, and I'll also do a regression video. And then on Saturday or absolute latest Sunday, I'll do one on GLM. So anyway, I hope this was useful. Please post up as many questions as possible. I would probably prefer that you post them up on the Facebook page for the subject. It just makes it a lot easier than posting it up on YouTube. So anyway, I hope that was helpful. And yeah, let me know if you need any extra assistance. Okay, thank you. Bye.